Okay, hello. My name is Guilherme, and I'll talk a little bit with you about how to essentially write what you expect to be highly scalable and provenanceable data pipelines using Kubernetes and Python. I mean, you can see that I love those buzzwords, but yeah, let's go. So currently I work at Precise. We are just quickly a digital marketing agency. We are founded in 2012. Right now we have about 250 employees, and we have 8 offices around the world. But the thing is, we write some proprietary technology, like we have our secret sauce for dealing with digital marketing, meaning like AdWords, Facebook. And that's essentially what I work with. And we're good. We won a few prizes, like best large PPC agency in Europe. All right. And we are hiring, but more on that later. So, I mean, given the last presentation, I guess there is at least one person here who deals with data flow or maybe machine learning workflows or something like that, but maybe raise your hands if you do something like that. Like, do you work with like data pipelines or something? Okay, yeah, more words. Yeah, I mean, for me, I consider it something hard, like you're dealing with those crazy tools. And you also have issues, like you have this data pipeline and it consists of several steps. How do you deploy or iterate each step separately? Like, can you have some sort of versioning? Can you deploy it separately, independently? And then you might hit stuff like, how do you scale them? Like, okay, you can iterate on them separately, but can you scale them independently? And can you distribute them in a cluster? Okay? And now there is new buzzword, data provenance. It's basically being able to track down or upstream the origin of the data. That's a huge deal, I would say, like GDPR, whatever. Now, I'm going to show you guys a solution. Like we found out, it's called Pachyderm. Now, the funny thing is, the main reason I'm doing this presentation is not to share knowledge. It's because they sent those T-shirts, okay? And I have like 20 of those. It's new stuff, new design, coming out tomorrow, super exclusive. So I have like 20, and you guys are 300 people. So at first I thought like Hunger Games, but that seems a bit too harsh. So, like, given the last presentation, I think I'm giving myself a shot in the feet. But who asks questions get the T-shirts and get to skip the Hunger Games after? Okay. Okay, but be nice. So yeah, about Pachyderm. I mean, I know you guys in the back can't read probably, and I moved a little bit, but this one's a bit big, so I'll just read for you. So the good part, my opinion, uses Docker for workloads, so it's like completely agnostic to language or whatever. It handles deployment and scalability via Kubernetes, so you can, like Kubernetes is a huge black box, or it can be white box as well, but you leverage all those DevOps and good stuff, more buzzwords. It also provides you data provenance out of the box. So you can get some piece of data and track upstream where it came from. So interesting. Now the bad. Installing and deploying it can be challenging, especially if you don't have this DevOps background, okay? But like if you do, then it's easy. It's like super easy. And the documentation is always work in progress, but they're making great progress there. And they are super responsive in the Slack channel. Now the ugly. It's like Kubernetes and Docker, if you never worked with it, it's messy. But if you did, it's good. So yeah, but the ugliest part is it's written in Go. And this is Python, so it's bad. At Precise, we have like, right now we have one pipeline running. And like it looks like this, okay? Those blue things are repositories. More on that later. And the blue things with green things are the pipelines, okay? So you can see you can have all kinds of meshes. Pachyderm has this DAG. I think DAG goes for direct acyclic graph. I didn't look it up this morning, just to be sure, but yeah, so you can essentially build any kind of pipeline. Maybe that they don't support very well, like something that's recurring, but that's another story. And then usually what you would see and be happy is this in the right part of the screen, like everything green, success, etc. But yeah, it's all fun and games until you hit something like this, like failure. And this is like every morning for me, right? Like sometimes it's green, sometimes it's red. And at least for us at Precis, these red messages are cause number one for office depression. It's really bad. It's really bad. So yeah, enough of these. Let's maybe talk with the presentation gods, and hopefully it will work. Okay. So I got here like a few examples. This one is relatively simple. This is a declaration of a pipeline in Pachyderm. Can you guys see this in the back? I will be describing anyways. So this first part here is just the name of the pipeline. That's straightforward. But maybe pipeline in Pachyderm, it is more like a job spawner. It listens on a input repository, okay, for changes and process those, okay? Now, let's move on. Okay, so we have a list of input repositories, which again, Pachyderm deals with like, it's like a pub sub, kind of. It's listening for changes in those repositories, and then it's going to spawn jobs for you. But the different thing here is this glob thing. Okay, so this defines how Pachyderm will interpret your input data. This will define like how it should look for what we call datums. And datums are the most indivisible pieces of data. Okay, so they are the minimum things. It's like it could be a CSV or it could be a file. It's something that a job, when it runs, it has enough information to do its thing. Okay, so maybe we can actually, okay, see how I like you guys. I put it on the top. Maybe we can go to the terminal and create a repository called maybe test, something simple. Okay, so Pachyderm has the CLI, okay, and it's quite good to interacting with it. Now let's add a new file to that pipeline, to that repository, sorry. And a repository in Pachyderm is what you would expect, like in terms of Git. It basically deals with like data versioning, which is pretty cool. So put file, and then we created a repository called test, and you have branches in Pachyderm as well. And you define the data, /datum. Okay. It worked, yes. Control, list, file, test, master, okay? Our data is there. Now, let's maybe, you can also have this other syntax here, datum2. You can define the path to the file. And if we list again, now we have two datums. Now, the cool thing about this is it also has this command called glob. I think that's probably just it. And then you define the glob pattern. Glob file. And then it returns what like Pachyderm would think are the smallest indivisible pieces of data, which in this case, it is saying every file on the root. Okay, so every file on the root is going to be the smallest piece of data for us. If we had a folder, for example, we could put something like this. And then for it, like every file under the first folder is an indivisible piece of data. Okay, so then we have this transform section here, which is, like the name implies, is how you transform the data. Okay, so we're dealing with data pipeline, so you want to transform the data. You can define a Docker image here, again, Docker, and you can define the command. And in this case, it's a command that's going to listen to a standard input, so we can also define standard input for that command. This is not super important. But yeah, what this pipeline is going to do is essentially, it's going to echo some message. It's going to list all the files in the input repository that we defined here, okay? And then it's going to echo the file path, okay, for each of those files. Now, our glob pattern here it's saying that every file on the root is going to be a datum, and every job deals with a single datum. So this for here is not really necessary. But anyways, now we need to create that pipeline. If we do pachyderm create pipeline, and then we provide a file, it's pipeline.json. It's going to fail because we don't have the input repository. So you can go ahead and create it. Create repo. Now, we are on Kubernetes, so we can list the pods for our Kubernetes cluster, and it's not created yet, but you can keep trying. OK, so there we go. It's still initializing, but that should be done quickly. OK, it's running now. Another way to do that could be maybe list pipeline on pack control. OK, it's starting, but it actually means like waiting for input. Now let's commit that file again into our input repository. Put file. Now it's first example input on master. By the way, like on the input section, you define the branch that you're listening to. By default, it's master. And then we get a file, datum. And then you can list the jobs, hopefully. Yeah, it's running. Super quick, should be ready by now. Then we can get logs. OK, cool. It's essentially what you expected. Like it's listening to the datum. This here is like internals. You don't need to care about this. But you're not going to be iterating over .scratch. You should iterate over the PFS input repository. All right, but then now just quick thing, like it comes with Kubernetes. So you can use the usual Kubernetes monitoring solutions like Prometheus, Grafana. And in our case, we use those, but we also use Elasticstack for the logs. That's something you should do, because every time you deploy a new version of the pipeline, it will kill the old pod, and with it goes the logs. So yeah, set up some logging infrastructure if you're going to do something like that. Now, let's keep going. The second example is now 2 pipelines. Okay, the first one is just going to take the input and add some data to it, like some text. And the second one is going to print it while also adding some text. OK. Now, yeah, so one detail here is the first one, I'm still going to use the same input repository, but the second one is going to listen to this first pipeline. OK, and this is the name of the first pipeline here. So output repositories are, they have the same name of the pipeline. OK. So yeah, let's delete everything to make sure you're in a clean state. OK, path control, create pipeline. Yeah, it's going to fail again because input repository. Path control, create repo, create pipeline. Second one. And now this one is actually getting the content of the file. So this file here is just some dummy input. Okay. Now let's commit it. Now I'm doing everything via the command line, but they have clients for languages as well. Like they have a Python client that could do pretty much everything I'm doing here. And if you're that kind of person, you can even go down in the protobuf level and interact directly with the Pachyderm daemon. But yeah, so input repository at master datum. All right, the first one's running. So we can maybe now, it's probably ready by now. So you can list the files from this output repository, which again has the name, same name as the pipeline, the master. It's here. And we can do a get file. So it's essentially doing exactly what we expected. Like get the content of the file, add this, and spit it out. Okay. So here's another thing. To put some file in the output of the pipeline, you just write it to PFS out. Like this is something really cool that Pachyderm does. It is essentially the data transfer between the pipelines done via the file system. Okay, so it's very transparent. You can just put a CSV there and deal with it, and then spit another CSV, okay, or something like that. We probably have already the get file second pipeline. Let's list first. Yep, it's here. Yep, it added this new thing. Okay, so this is like a simple way to chain your pipelines. All right, this third example, it is a bit more complicated, but let's see how it goes. So now we have some Python code here. Essentially, we have two. I'm going to still have two pipelines. Okay, the first one is simulating the data ingress. So you can think of it as, for example, grabbing data from S3 or like some data lake or some API. Okay, but in this case, it's just generating some random data. And then it's writing back to Pachyderm. And again, to write back to Pachyderm is just like normal file system operations. Okay, so that's pretty cool. And here we are iterating in all the input files. Okay, if our data was more than one, we would have to change this a little bit. Then we're basically getting the, okay, so the input here now is going to be, it's more realistic. It's like a config file, it's like some JSON. So we're going to read it, okay, parse it, get the informations that we want, and based on it, we are going to get the length and the headers that we expect in our output, length and headers, okay? And we're going to generate a random data frame, okay? The second one is going to get, the boilerplate is very similar, but what it's going to do is it's going to get it and sum each column, okay, and output it. So it's super simple, but the difference here is it is going to, each column is going to go to a different file. That's the main difference here. Okay, so like we have here, our write to Pachyderm is iterating over the columns and then writing one file for each. Clean state again. Oops. Pachyderm. Okay, so let's deploy. Yes, one detail. Oh, I changed something here. One detail is those are now using actually Docker files. So that's pretty neat. As you guys are going to see, pachyctl also has this utility built in that automatically pushes the image for you to some Docker registry. In our case, I'm going to use the default Docker Hub thing. Okay, I came here and created two repositories for this presentation. So since Kubernetes, that's also another cool thing. You guys can try this out. Google Cloud, like Google Cloud gives you like I think 3,000 crowns for as credit. So you can do so much stuff with it. Like I created this one like 3 days ago, and I still have 2,700 crowns. That's a lot. Yeah. So okay, cool. And you define a command like Python data ingress. That's simple. And you can put this in your CI or whatever to have some automatic deployment. Okay. So let's do this. Like so, the logic step would be to get. Yeah. So you take your Docker file, you build it using it, and tag it with the image that you expect. Docker build. Okay, and then you can do like this actually. Pipe control, create pipeline, and then push images. And this is going to automatically re-tag your image. It's like creating a new tag here and pushing it to the Docker registry. Yeah. Okay. Yep, there it goes. Let's create the second one. Same thing. I don't need to build it because I already did that. Create pipeline. Okay. There we go. Should have 2 here. Yep. Let's put some data and see what happens real quick. And then we got the repository at master data.json. Okay, it's running. Merging. Yeah. Okay, cool. So this is the final job. It should be ready already. Let's get the file. Let's list actually. List file. Let's go straight to the second pipeline. Second pipeline. Okay. It's gonna list like one thing that I did is I created a folder with the same name of the file, just for simplifying things. Let's actually list on data1.csv. Then there you go. Like we had those 3 columns here as input with like random numbers, and if we do a get file in one of those, like column A, there you go, should be the sum of the random numbers that were generated. All right, and now one thing that I should mention as well before we wrap up is Pachyderm has some smart merging of data. Okay. So if you have, like we saw what datums are, but the datum doesn't need to be just one input, one output, okay? You can be like one input, multiple outputs. It can, like, you can have the datum right into the same file as another datum, okay? So in the first case, in the left, it's really simple, like one datum, one run, one output. But you can have something like on the right, okay? You can have like a datum, then it, by being processed, it generates 2 files, okay? And then Pachyderm is gonna merge those 2 files with other jobs that are maybe using those same 2 files, okay? And Pachyderm is very based on appending files, okay? That makes a lot of sense if you're using like CSV data, series data, okay? But you need to maybe think a bit about your mental model for that, okay? And again, we are hiring at Precis. Like I noticed we have a lot of data scientists here, but we are hiring more specifically backend developers. Is there any backend developers here? Okay, good. Okay, nice. We're hiring seniors and juniors, so everyone's welcome. And questions. I have the code here on this repository if anyone wants to take a look.
So it's time for questions and Hunger Games. Oh.
Hi. So I don't want to volunteer for the Hunger Games, so I'm just gonna ask, can I have a t-shirt?
Yes, you can. What's your size?
A size small.
What?
An S.
Oh, okay, you got it. That's the kind of questions I wanted, yes.
Well done. So any more questions?
Good.
Hi, thanks for the talk.
Thank you.
So have you tried out, have you compared this to any other task systems like Airflow and Luigi and stuff?
Yes. Yes, that was an expected question, actually. Thank you for asking. Yeah, so like it's a bit hard to compare with Celery, maybe, because Celery is a different beast. Okay, it's like Celery doesn't help you much with scaling or whatever, but Airflow is actually pretty similar, right? People use it for data flows. They use it for ETL. But in my opinion, the main difference here, like the biggest difference, is data provenance. Okay, so Pachyderm is going to help you a lot with data. Okay, it's built for machine learning workflows, for like exploratory data analysis, these kind of things. Okay, and like maybe on another topic, I would say that deploying Pachyderm, if you know Kubernetes, is super simple. It's literally like a few commands. Okay. Whereas like Airflow, I'm not really sure. Like they're not very opinionated regarding where you should put it. In my opinion, that's not great. Okay, but yeah, like Airflow is built on Python, so it's good.
So any next questions?
Hi, thanks for the talk. I was just wondering if there's a way of running cron jobs or some kind of time stuff.
That's actually good. Yeah, there is. I can actually bring the documentation. I mean, this is old. Okay, they just released it yesterday, and I got scared this morning when I were like reading for the presentation. But yeah, like two things I didn't show. They have this parallelism spec, which is interesting. It's not necessarily directly related with your question, but it defines how many datums you can process in parallel in a single job. Okay, so I mean the datums are already independent, so why not process them in parallel? And then Pachyderm deals with merging after. But specifically to your question is we have these kinds of input here. Okay, we have PFS, which is the more basic one I was using. We have cross and union, which essentially they allow you to combine different repositories as input, and you have cron. Okay, so yeah, you can do like you can use I think the cron syntax and maybe the rate syntax, but yeah, you can do that.
So any more questions or T-shirt requests? Okay.
Okay, we're good.
Thank you, Guilherme.
Thank you.